Okay, my dear students, we are just going to start studying further. Yesterday we have seen about few of the very important points. Let me tell you that dehydration is the removal of water molecule from alcohol. So here we are going to study the dehydration of alcohol. You can see here that the general reaction for the dehydration of alcohol is given here. You can see that an alcohol has got hydrogen and OH group. So this H and OH is removed as an H2O and we simply get an alkene. And this is how, my dear students, we can understand the dehydration reaction. So here in this example, you can see that ethanol, when it is heated with sulfuric acid at 443 Kelvin, it turns into ethene and water molecule is removed. This is the important example of the dehydration. Now, my dear students, we want to study about the mechanism of dehydration reactions. So the next thing what we are going to study about is the mechanism of this dehydration reaction. So let us study the mechanism of dehydration reaction step by step. So what happens if we, like as we start studying about the mechanism of dehydration reaction, first we have H2SO4 that turns into H plus and SO4 minus 2. This H2SO4 which turns into H plus and SO4 minus 2. This H plus, this H plus is utilized into the next or the first step. So this is your H plus. This H plus is attacked by the two electrons which are present in your ethanol. So you can see the attack of oxygen. This H plus, as it is having positive charge, it is electron deficient. So as this H plus is electron deficient, it is attacked by the oxygen and this is how it gives us the new product. This is a fast step and in this fast step you get a new product which is known as the protonated alcohol or ethyl oxonium ion. Now my dear students, in the second step, this protonated alcohol or ethyl oxonium ion undergoes. So this protonated alcohol or ethyl oxonium ion, in the slow process, in the slow step, actually what happens, this bond is being broken and both the electrons of this bond go to oxygen. And this is how, my dear students, we can even show that there will be 4 electrons present on the oxygen of water. You can see here. And this H2O is removed as a complete molecule. As this, both the electron of this bond goes to the oxygen, this carbon has deficiency of electron and that is why it turns out to be carbocation. So here we get a carbocation produced in the second step. Now my dear students, we are going to study about the third step. So this carbocation which is produced into the previous step, which is also known as the second step, my dear students, this carbocation undergoes the particular process. So let us move to the step number 3. In this step number 3, my dear students, we can say this step number 3 as the formation of ethene by elimination of a proton. So in this particular step, this is the carbocation that we have. So this carbocation, you can see that this hydrogen goes away as an H plus. This hydrogen goes away as a H plus. The electron of this bond comes to this and that is how this double bond is being formed. So this double bond is formed because the electron from this bond goes to the carbon and both the carbon make the double bond, and that is how we can get a product which is an alkene. This is also known as ethene because it has got two carbon. We name it as ethene, but this is the alkene. That is what we get as a product, and this H plus is removed. The acid H plus used in the step 1 is released in the step 3. That is why we call it as a catalyst. So we use H2SO4 as a catalyst, and this H plus from H2SO4 that we have used is completely, it comes out as H plus, and that can be again used into the first step. To derive the equilibrium to the right side, ethene is removed as it is formed. So you can see that this is the reversible equation, and as this equation is reversible, we can easily understand that from this to get the maximum product, we need to remove the ethene time to time. So ethene is removed as it is formed. So if we keep on removing this ethene, we get more and more or better and better product. So my dear students, this is what it was, the end of the mechanism. Bachcho, is there anything else, like if there is something you could not understand, you can ask me. अगर इस मैकेनिज्म में आपको कुछ समझ में नहीं आया तो आप मुझे पूछ सकते हैं प्लीज. बच्चों ये मैकेनिज्म जो हमने पढ़ा, हेलो आप मुझे सुन पा रहे हैं?
Yes, sir.
उसमें अगर आपको कुछ समझ में नहीं आ रहा तो आप मुझे पूछ सकते हैं.
Yes, sir.
तो चलिए let's move and see the few other examples. We have already seen one example. Example number 1. This is your example number 1. This is example number 1, that by the dehydration of alcohol, we get alkene. So ethanol undergoes the process of dehydration and then we get ethene. Now my dear students, we are going to study the second example, example number 2. Secondary and tertiary alcohols are dehydrated under milder condition. Milder condition, let us see what are those milder conditions. You can see 2-propanol, that is CH3CH3OH. It is converted into prop-1-in by heating at 440 Kelvin and in the presence of 85% H3PO4. Please remember that if you have secondary alcohol, this is secondary alcohol. So if you have secondary alcohol, the secondary alcohol is converted into alkene by heating it with the 85% H3PO4 at 440 Kelvin. But if you have tertiary alcohol, remember this is 2-methyl 2-propanol. This 2-methyl 2-propanol is tertiary alcohol. So as this is the tertiary alcohol, 2-methyl 2-propanol, if you want to convert it into the methyl prop 1-in, then it is converted by 20% H3PO4 and 358 Kelvin. So you just need to even decrease the concentration, and you can see that even the temperature has been decreased. Initially for primary alcohol, remember for primary alcohol, we need 443 Kelvin temperature and concentrated H2SO4. For secondary alcohol, my dear student, for secondary alcohol, we take 85% H3PO4 and 440 Kelvin, but for tertiary alcohol, we take 20% H3PO4 and 358 Kelvin. So these are the milder conditions, and that is how, my dear students, we can say that secondary and tertiary alcohols can be dehydrated under the milder condition. Please remember that secondary and tertiary alcohols can be treated with the milder condition to get the alkenes. Thus, relative ease of dehydration. Please remember, relative ease of dehydration मतलब कौन सा अल्कोहल कितना इजीली डिहाइड्रेट होगा, which alcohol is going to be dehydrated easily. So you can easily understand that tertiary alcohols can be dehydrated easily at the milder condition. Secondary alcohol give little harder conditions, and primary alcohol need most hard conditions. So the ease for the dehydration of alcohol is tertiary is greater than secondary is greater than primary. So this is how, my dear students, we understand about the dehydration of alcohols. Now, if you have any doubt, my dear students, in this, you can ask me, or we can move to the next topic. बच्चों, अगर आपको कुछ पूछना है तो आप लोग मुझसे पूछ सकते हैं अभी, या फिर हम आगे चलते हैं. ओके, तो चलिए, आई थिंक यू डोंट वांट टू आस्क एनीथिंग. यू आर फ्री टू आस्क इफ यू कुड नॉट अंडरस्टैंड एनीथिंग. क्या बच्चों समझ में आ गया है?
Yes,
Yes.
sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Let's then study the each method for the preparation step by step. Now we have studied this topic into the previous chapter with concentrated halogen acids. You know, in the previous chapter we have seen that when alcohol reacts with HCl in the presence of ZnCl2, they give RCl. So you can see that we can convert alcohols into haloalkane. How can we convert alcohol into haloalkanes? So we can take primary alcohol and allow it to react with HCl and ZnCl2. Now anhydrous ZnCl2, please remember, my dear students, that anhydrous ZnCl2 in the presence of HCl is known as Lucas reagent. Please remember, anhydrous ZnCl2 in the presence of HCl is known as the Lucas reagent. So, my dear students, we are going to study the Lucas test or Lucas reagent in detail. So, when we have secondary alcohol, or first of all, please remember that anhydrous ZnCl2 in the presence of HCl is known as Lucas reagents. Now, what is the speciality of Lucas reagent? Let us see. It produces turbidity at room temperature after 5 minutes with secondary alcohol. If we have the secondary alcohol, Lucas reagent produces turbidity after 5 minutes. If in case of the tertiary alcohol, my dear students, in case of the tertiary alcohol, Lucas reagent produces immediately turbidity. So turbidity is immediately produced in the presence of tertiary alcohol with the Lucas reagent. So the question arises that why turbidity is produced, or why do we call it turbidity? So alcohols are soluble in Lucas reagent, but their halides are immiscible. Immiscible means they do not dissolve easily, or they are not dissolved easily. That is what they are known as the immiscible with Lucas reagent, and thus produce halides precipitate. Precipitate means they turn out into the solid form, and these precipitates shows turbidity. So please remember about the Lucas test, that Lucas test is used to identify the primary, secondary and tertiary alcohol. How do we perform the Lucas reagent, Lucas test? We add concentrated HCl and anhydrous ZnCl2 to the given alcohol. If turbidity is produced immediately, we can say we have the tertiary alcohol. if turbidity is produced after 5 minutes, we can say that we have secondary alcohol. But if turbidity is not produced at all, if turbidity is not produced at all, we can say it primary alcohol. Then what we can say even something further, because why turbidity is not produced in case of the primary alcohol? Because primary alcohol do not react, primary alcohol do not react, my dear students, at all with Lucas reagent. So as this primary alcohol, they do not react with the Lucas reagent. They do not produce any kind of turbidity. Now, my dear students, we are going to study the reaction of few more production of few more halides from the halogen. So you can see that PCl3 and PCl5 are also used to produce halide from the alcohol. So you can see that if you have an alcohol ROH, and if you take PX3 where X is equal to Cl or Br, so it can be PCl3, it can be PBr3. This PX3 can be PCl3 as well as PBr3. You get 2Rx. That 2Rx can be RCl or RBr. At the same time, S3PO3, this can also be written as POH thrice. This phosphoric acid can also be produced. Next thing is this, that if you have ROH and then we have PCl5, so you can turn it to be RCl, then you may have POCl3 and HCl. So remember, my dear students, that what do we need to remember here is, for 1 mole of PX3, PCl3 or PBr3, 3 moles of alcohol are needed and H3PO3 is produced. Apart from alkyl halide, my dear students, in case of PX3, we get RX and we get H3PO3. Same way in case of PX5, my dear students, in case of PX5, that is your PCl5, 1 mole of alcohol react with PCl5, POCl3 as well as HCl can also be produced. So this is something you need to remember it, that by using the Lucas reagent or by using the PX3 or PX5, we can produce alkyl halide from the alcohol. Now, my dear students, we are going to study about the oxidation of the alcohols. So let's move to the next topic and study about the oxidation of alcohol. Oxidation of alcohol involves the formation of carbon-oxygen double bond with cleavage of an OH and CH bond. Please remember, my dear students, that when we oxidized any alcohol, the alcohol is oxidized by breaking its two bonds. That is, one bond is the bond between this carbon and oxygen. Another bond broken is the bond between oxygen and hydrogen. So these two bonds are being broken. Please remember that when we oxidize the alcohol, these two bonds are broken and a new bond formed. That is the bond between carbon and oxygen, which is a double bond. So this is what it happens when we oxidize any of the alcohol. Now breaking up of bond is known as the cleavage. So such cleavage and formation of double bond, also known as dehydrogenation. This process is also known as the dehydrogenation. Depending upon the oxidizing agent, primary alcohol is oxidized to aldehyde. Remember, primary alcohol gives us aldehyde, then turn into carboxylic acid. So if you keep on oxidizing, this aldehyde turns into carboxylic acid. Strong oxidizing agent will convert alcohol directly into the carboxylic acid. So remember, we have oxidizing agent for oxidation. For oxidation, my dear students, we need oxidizing agents. You can easily understand. We need oxidizing agents. This oxidizing agent can be of two type. This oxidizing agent can be of two type. One is mild oxidizing agent. Another one is known as the strong oxidizing agent. So what is the difference between the mild oxidizing agent and strong oxidizing agent, my dear students? That this mild oxidizing agent, if you have a mild oxidizing agent, then this mild oxidizing agent is going to be, this mild oxidizing agent, if you take alcohol and use this oxidizing agent which is mild, it turns alcohol to aldehyde. And the same aldehyde, when oxidized with the mild oxidizing agent, it turns itself into the carboxylic acid. But suppose if you have the mild oxidizing agent, please remember, instead of mild oxidizing agent, my dear students, suppose you have strong oxidizing agent. So if you oxidize any alcohol with strong oxidizing agent, then it converts alcohol directly into the carboxylic acid. So this is the basic difference between the mild oxidizing agent and strong oxidizing agent. Once again, I am going to read the text for you, my dear students. Please pay attention. Primary alcohol is oxidized to aldehyde, and aldehyde then turns into carboxylic acid. Strong oxidizing agent will convert alcohol directly to the carboxylic acid. Secondary alcohols are oxidized to ketones, and tertiary alcohols do not undergo oxidation reaction. Tertiary alcohols, if tried to oxidize, they give dehydrated products. So let us understand this topic one by one. We have even seen that if we have primary alcohol, if we have primary alcohol, by oxidation, they may give aldehyde. If we have secondary alcohol, on oxidation, they may give ketone. Tertiary alcohol do not undergo oxidation. And as they do not undergo oxidation, if forcefully if we try to oxidize, try to oxidize, when we try to oxidize, they give alkene. So this is what, my dear students, we are going to study into our next text. Let us pay attention. Let us study. Let us see with the example what we have discussed just now. You can pay attention. As related alkene, so first we have CrO3, which is a mild oxidizing agent. Please remember, this mild oxidizing agent reacts with the primary alcohol, your ethanol, your alcohol RCH2OH. It is the primary alcohol on oxidation with CrO3, which is a mild oxidizing agent. Please remember. So being mild, it converts alcohol into aldehyde. So from RCH2OH, you get RCHO. And again on oxidation with CrO3, which is a mild oxidizing agent, you get RCOOH, that is your carboxylic acid. But if you have secondary alcohol, like RCH, R-OH, on oxidation with CrO3, you will get ketone. So this C-O bond turns out to be C double bond O, and that is how you get ketone. Let us study the same with the more examples. If you have ethanol, if you allow it to oxidize with the mild oxidizing agent CrO3, it gives us ethanol, and on further oxidation with CrO3, it gives us ethanoic acid. Same way, if you have propanol, you remember, my dear students, that this was the primary alcohol and it gives us the aldehyde, and then it gives us the acid. So primary alcohol on mild oxidation give aldehyde and acid, but secondary alcohol, if you have, which is a 2-propanol, on mild oxidation, it gives us ketone propanone. So this is what we can easily understand. Next, suppose you have one more. Now we are going to study one more oxidizing agent. This oxidizing agent is known as the Jones reagent. This Jones reagent is strong oxidizing agent. Please remember that Jones reagent is a strong oxidizing agent. It is made up of CrO3 in the presence of concentrated H2SO4. So if you take butane 1-ol and allow it to react, allow it to oxidize with the Jones reagent, you can directly get butanoic acid. So you do not get butanol because Jones reagent is a strong oxidizing agent. Same way, my dear students, if you take propanol and allow it to, if you oxidize it with the acidified KMnO4, this acidified KMnO4 is also strong oxidizing agent. Then you get propanoic acid, CH3, CH2, COOH. Same way, my dear students, if you take cyclohexanol and allow it to oxidize with the mild oxidizing agent CrO3, you will get cyclohexanone because this cyclohexanone is secondary alcohol. If you cannot understand, let me show you that this carbon which is bonded to OH is bonded with 1 and 2 other carbon, and that is why your cyclohexanol is secondary alcohol which turns out to be cyclohexanone, which is a ketone. So this is how, my dear students, we understand about the oxidation of the various alcohols. Let us move forward to study more about the alcohols. Now, my dear students, we are going to study about a very important oxidizing agent which is known as PCC. Please consider it as an important reagent because it is specific and very interesting. The full form of PCC is pyridinium chlorochromate, a complex of pyridine HCl and this is the complex of pyridine. This is the complex of pyridine HCl My dear students, I'm sorry, there is something wrong with this machine. I'm not able to handle it well. Just 1 minute. Give me some time. I shall do it. I shall correct it. Yes, uh, it's done. Sorry, I apologize for this. But we are talking about the PCC, which was the pyridinium chlorochromate. We should end our class here. We should discuss about PCC into the next period. अगर आपको कुछ समझ में नहीं आया तो बच्चों आप पूछ सकते हैं. Hello, dear students, can you hear me?